Hey guys, welcome to the second part of the 9.5 video. I wanted to do just a few more examples for you to make sure that you guys were in good shape to solve these problems as we change pieces of information on our polygons. So yesterday we were talking about regular polygons where in each of the case the radius was given, but in some of your examples moving forward they might give you the apothem instead. And actually, that makes our life a little bit easier. So I'm going to work just a couple more examples in case you're struggling to put this all together here. Remember that we're using the formula area equals 1/2 perimeter times apothem. And so in a problem where they give you the apothem, actually your life is easier because all we have to do is find the perimeter, which means for our shape, we just have to find that side length. So, okay, again, we're going to draw in our right triangle and label the information. This is the apothem. This is that opposite side that we don't know. In this case, the apothem is 6. We have our right triangle. And actually, we don't need the radius, right? The radius was helping us solve for both the apothem and the side length. But when they don't give us the radius, there's actually no reason for us to need that information. So that saves us compiling some of the work here in order to use the formula for the area. Okay, so we're going to proceed just like we did before in terms of finding those central angles. This shape is a pentagon. So we're going to take 360 divided by our number of sides, which is 5. And that gives our central angle to be 72 degrees. So again, just for reference, it means that central angle is 72 degrees. But of course, we don't want that one. We want half of that. So if we divide that by 2, then we get our angle to be 36 degrees. So this is 36 degrees in there. And remember, that's our reference angle. This is 6, our apothem. This is the opposite side that we're looking for. And there's 36 degree angle. All right, so now in reference to this angle, we need the opposite and we have the adjacent. So we're going to use the tangent. So the tangent of 36 is the opposite over the adjacent. If we solve for O by multiplying both sides by 6, then we get 6 times the tangent of 36. And that opposite side then is going to be 4.359. All right, remember though that that's only half of the side length. We have to double that to get the whole thing. So if I multiply that by 2, I'm going to get 8.719 for my whole side length. And maybe that's worth noting here. Side length is 8.719. And then to get the perimeter, I multiply that number by 5. And that's going to give me 43.593 meters. All right, and they gave me the apothem, so now we're ready to go. We have 1/2 the perimeter, which is 43.593 times the apothem, which is 6. And when I put that all together, I'm going to get 130.8 meters squared. All right. So go ahead when you're ready. Let's move to the next one. This time we're dealing with a hexagon. So we have a 6-sided figure. And again, they give us the apothem, which makes our life a little bit easier. So you're going to go ahead and draw in your triangle, your radius and your apothem here. Here our apothem is 4. Our opposite side we don't know. And now we're looking for that angle measure in the middle. So you take 360 divided by the number of sides, which is going to be 60. And I want half of that for the angle of my triangle, which again, these hexagons, if you realize then, are kind of a good thing because they are going to give us a 30, 60, 90 triangle, which makes our life a little easier. Now, you are welcome to use a trig function like the tangent to find O, or you can use our side ratios for that 30, 60, 90 again. So this is the 60, this is the 30. So this means this is the 1, this is the 2, this is the square root of 3. It makes it a little trickier because our 4 is the square root of 3 ratio. But remember, we used another side ratio expression, x, 2x, and x root 3. So if you let 4 equal x root 3, or root 3x, and we divide by the square root of 3, now we have to rationalize. And you're going to get 4 root 3 over 3. Now I know that makes us feel uncomfortable, but I want to solve it using these radicals just so that you see it. But again, you could convert that if you wanted to use the trig function, the tan, and use a decimal representation, we should get the same answer. Okay, remember that this x is half of the side length. Now I need to double that for my side length. So if I multiply this times 2, I'm going to get 8 root 3 over 3. And then in order for me to get my perimeter, I'm going to take 8 root 3 over 3, and I'm going to multiply that times 6. And then I'm going to get 48 root 3 over 3. But 48 is divisible by 3, you get 16. So this is 16 root 3. That's the perimeter. And now we're ready. So we have area equals 1/2 perimeter, which is 16 root 3, times the apothem, which they gave us is 4. And when you simplify that, we're simply going to get 32 root 3 meters squared. All right, I'm going to do one more example for you. I think this is like the hardest combination that they might give us, so I wanted to do just one more. Let's look at a decagon. So a decagon is a 10-sided figure, and it's very difficult to draw. Keep in mind that mine is not great. You should try to draw it. It's more challenging than you think. They give us a decagon, and they give us a radius. So for my example, I'm going to make the radius 10 meters. And this is just a little bit more challenging because, again, we're not going to end up with a 45 right triangle or a 30, 60, 90. So that angle measure is going to be really small, and I just wanted to walk through it with you. All right, and we're going to have to use our trig functions. So to begin, we're going to take 360 divided by 10, gives us our central angle as 36 degrees. But we don't want that. We need to divide it by 2, and we want our angle measure to actually be 18 degrees. All right, so now we're going to have to use both of those trig functions like we were practicing yesterday. So we can start with the sine. So the sine of 18 degrees is the opposite over 10. O is going to be 10 sine 18. And when I round that off, I'm going to get 3.090. All right, similarly, I'm going to use the cosine, which is the adjacent over the hypotenuse. So A, also the apothem, is 10 cosine 18. And when I multiply that out, I'm going to get 9.511. Okay, so now remember that our O is only half of the side length. We need to double it to get the whole side length, which is going to be 6.180. And then when I multiply that times 10, I get my perimeter to be simply 61.803. All right, now we have our perimeter and our apothem, so we're ready to go. So 1/2 perimeter, which is 61.803. times our apothem, which is 9.511. And I multiply that all out, and I'm going to get 293.9 meters squared. Okay, I just wanted to put a few more examples in your arsenal. Hopefully this is making sense to you, but when you're ready, finish up your notes and begin today's assignment.